Time back up again.
ଆଜ୍ଞା 9 ଜଣ ସାର୍ ଆସିଲେଣି ବର୍ତ୍ତମାନ।
পেপারটা হচ্ছে কোশ্চেন। କେତେ ଅଛି? Very good afternoon, all of you. And only 32. Alok Pani. जगन्नाथ पाल, नमस्कार। वेरी गुड आफ्टरनून, सौभाग्य। शिपुन, नमस्ते। Mathematics classes, your name? You should be very sincere. I have told you to come at exactly at 2. नीलू साहब नमस्कार। सोहेल गुड आफ्टरनून। वेरी गुड आफ्टरनून नरेंद्र। नमस्कार मोनाली महापात्र। मुन्ना भुतिया गुड आफ्टरनून। वेरी गुड आफ्टरनून अमृत विनय। Shibun, you are from physics department or mathematics department? You are in +3. Or doing M.Sc? So, statics and mechanics, your requirement. From which college you are? Okay, very good. JKVK college. Ravi sir is there in mathematics department. Very good afternoon, Gayatri. Good afternoon, Asutosh. Start करो. Oh, Dhiren sir, he was in Denkanal, Women's College. Dhiren sir from Denkanal Women's College, and he knows me very well. Ask him about me, he will tell you. Just ask him about Khillar sir from Denkanal, he will tell you. See here, and today I am going to tell you, first of all, very good afternoon to all of you, and today I am going to tell you about real analysis. And in real analysis, very important part is your convergence and how to test convergence of a sequence. Actually, a sequence may be convergent, may be divergent, or neither convergent nor divergent. May be convergent, may be divergent, or it may be neither convergent nor divergent. Clear? But question is that when a sequence is said to be convergent, under what condition a sequence is said to be convergent, and under what condition a sequence is said to be divergent? See here, if you are going to become a lecturer or professor, or you want to do Ph.D. or you want to do M.Sc, it is very important that you should know about convergence. See here, this is important for both physics department and mathematics department, because in physics department there is convergence of a sequence, power series there, Taylor series, Maclaurin series, all are in physics department also. And you have to find out the radius of convergence also. And you have to find out whether a series sequence is convergent or not. Clear? So it is important for both physics and mathematics department. But when the students are facing problem in M.Sc, they are telling that let us keep this paper, just clear this paper, and we will do lectureship. But when you will do lectureship, or when you will become a professor or assistant professor, you have to teach analysis, and that paper is very, very important. And maximum, see here, in my life I am seeing that 80% students cannot teach real analysis. So that means if you want to be a lecturer, or if you want to be an assistant professor or professor, you have to teach real analysis, and the real analysis is in B.Sc and is also in M.Sc. And actually practically it is very, very important. In class 7th, 8th, 9th, 10th also real analysis is there. For example, in B.Sc you are doing the proof that A into B is equal to 0 implies either A0 or B0, but that property is in your class 8th. Okay, A into 0 is equal to 0, that proof is not there in your school career, but you are doing the proof. 1 is greater than 0. Clear? You are doing the proof. And the property which you are applying in the school career, school teachers are saying that simply apply the property, simply remember the property, and the proofs are in your college career. But in your college career you are skipping those proofs. In your school career, the teachers are saying that you will read the proof in the college career, but in the college career you do not know this proof, or you are not interested to the proofs. Okay, that is the problem. So that is why our education system is going down and down and down and down. Clear? So first of all, see, under what condition a sequence Xn is said to be convergent or is said to be divergent. Under what condition the sequence Xn is said to be convergent or is said to be divergent. Clear? It is said to be convergent if limit n tends to infinity, Xn is a finite value, finite real number. If the limit of Xn as n tends to infinity is a finite real number, then the sequence Xn is said to be convergent. Clear? And if the value is infinity or minus infinity, then the sequence Xn is said to be divergent. Clear? And what type of sequence is neither convergent nor divergent? For example, 2 1 2 1 2 1 2 1, like this, and so on. Clear? This is an oscillating function. It oscillates. 2, then 1, then 2, then 1, then 2, then 1. So its limit is neither a finite real number nor plus infinity or minus infinity. That means this type of sequence is neither convergent nor divergent. Clear? See here. Question is that how to test whether the sequence is convergent or divergent. Clear? First of all, remember, if the limit of a sequence as n tends to infinity is a finite real number, then it is called convergent. And if the value is plus infinity or minus infinity, then it is simply divergent. Clear? So question is that you are taking the limit as n tends to infinity. First of all, I want to give you some idea how to find out the limit as n tends to infinity. Clear? I want to give you 3 rules. See here, limit n tends to infinity 3n square plus 2n plus 5 divided by 4n square minus n plus 2. So here n tends to infinity is there and the degree of numerator is 2 and degree of denominator is also 2. That means the degree of numerator and denominator are same. So in that case the result will be 3 by 4. 3 by 4. See here, that means the coefficient of highest power of n square divided by the coefficient of highest power of n square in the denominator. In the numerator the coefficient of n square is 3 and in the denominator the coefficient of n square is 4. So answer is 3 by 4. Directly you should write 3 by 4. Okay. And another, limit n tends to infinity 3n square plus 4n divided 2n minus 5. So here the degree of numerator is greater than the degree of denominator. Here the degree of numerator is greater than the degree of denominator. So in that case the answer will be infinity. Clear? Now another, limit n tends to infinity 4n minus 1 divided by 2n square plus 3n minus 2. Here the degree of denominator is less than the degree of numerator, is greater than the degree of numerator. That means the degree of numerator is less than that in the degree of denominator. So in that case the answer will be 0. See, there are 3 cases. In the first case, the degree of numerator is same as that of denominator. In the second case, the degree of numerator is greater than that in the denominator. In the third case, the degree of denominator is greater than the numerator. So if the degree is same, the answer will be coefficient of highest power of n in the numerator divided by coefficient of highest power of n in the denominator. In the second case, if the degree of numerator is greater than that in the denominator, the answer will be infinity, and if the degree of denominator is greater than numerator, then the answer will be 0. So these are the 3 cases. Clear? So knowing these 3 values, you should apply the trick directly. Clear? So how to apply directly? See here, today I am going to tell you about D'Alembert's ratio test. And what is D'Alembert's ratio test? n is a positive term series. Summation n is a positive term series. Clear? And find the limit n tends to infinity an plus 1 by an plus 1 by an. Clear? And if the value is L, let the value be L, and the condition is that if L is less than 1, then summation n is convergent, and if L is greater than 1, then summation n is divergent, and if L is equal to 1, then test fails. Test fail means you cannot say anything about the sequence by this ratio test. That means we have to switch over to another test. Find the limit as n tends to infinity of an plus 1 by an, let it be L, and if L is less than 1, then summation n is convergent. If L is greater than 1, then it is divergent. If L is equal to 1, then the test fails. Clear? So, now let us take some examples so that you can understand better. Remember, limit n tends to infinity an plus 1 by an. You have to find out. And find the limit of this one. Then you have to decide according to these three rules. Okay. I am taking first example. See here. An is equal to n square by 2 to the power n. N square by 2 to the power n. See here. Now an plus 1 by an limit n tends to infinity is equal to limit n tends to infinity an plus 1. Here an is n square by 2 to the power n, an plus 1. That means in place of n you should write n plus 1. So it will be n plus 1 whole square by 2 to the power n plus 1. This is your an plus 1 divided by an means this one, n square by 2 to the power n. So it will become limit n tends to infinity, write this one, n plus 1 whole square by 2 to the power n plus 1 into, just take the reciprocal, 2 to the power n by n square. Clear? So now 2 to the power n is there, here also 2 to the power n is there, so cancel out these two, then you will get limit n tends to infinity, so it is n plus 1 whole square divided by 2, there remain 2, then n square. If you will expand this one, see here, without expanding I can write what, see here, n square plus 2n plus 1 divided by 2n square. So I have told you, in case of infinite limit, if the degree is same, then write the coefficient of highest power of n divided by coefficient of highest power of n in the denominator. So here the coefficient of highest power of n is 1 and the coefficient of highest power of n in the denominator is 2, so 1 by 2 which is less than 1. So therefore by ratio test you should write, by ratio test summation n is convergent, because I have told you if L is less than 1 then summation n is convergent. See here, another question I am going to tell you. N is equal to, what is n? N is the nth term of the series. N is equal to factorial n divided by n cube. So how to do this one? See here, limit n tends to infinity an plus 1 by an is your limit n tends to infinity. What is n plus 1? Tell me. It is n plus 1 whole factorial divided by n plus 1 whole cube, and take the reciprocal of this one, n cube divided by factorial n. Now see here, limit n tends to infinity, cancel out these two terms, so that remain n plus 1. Because this one I can write n plus 1 into factorial n, and factorial n cancel out, and remain n cube divided by n plus 1 whole cube. Clear? Now this is limit n tends to infinity, n plus 1 one part cancel out, remain n cube divided by n plus 1 whole square. Clear? Now tell me, here the degree of denominator is greater than the denominator. Here the degree of numerator is greater than that in the denominator, and if the degree is greater than in the numerator, so the answer will be infinity, and infinity is greater than 1. And I have told you, if L is greater than 1, then summation n is divergent. So infinity is greater than 1, so therefore by ratio test summation n is divergent. Clear? So now let us see another example. Before that, see here one formula I am going to tell you. Limit n tends to infinity 1 plus 1 by n to the power n is equal to e, and the value of e is equivalent to 2.71. Limit n tends to infinity 1 plus 1 by n to the power whole to the power n is equal to e. See here, n tends to infinity and the value of e is 2.71. Clear? And now, how to find out or how to test the convergence of this one, 1 by n to the power n? This problem we can solve by root test also, Cauchy's root test. But how to do by ratio test? See here, by Cauchy's root test it will be very easy. In one line you can say, see here, limit n tends to infinity an plus 1 by an is equal to limit n tends to infinity an plus 1. What is an plus 1? 1 divided by n plus 1 to the power n plus 1 divided by 1 by n to the power n. So just take the reciprocal. 1 by n plus 1 to the power n plus 1 into n to the power n. So how to solve this one? 1 by n plus 1 into n to the power n by n plus 1 to the power n. Clear? So this can be written as, see here, limit n tends to infinity, it is 1 by n plus 1, and for second part, divide n to the power n in the numerator and denominator, so that the denominator will become n plus 1 to the power n by n to the power n, and this can be written as n plus 1 by n whole to the power n. N plus 1 by n whole to the power n. N by n is 1 plus 1 by n to the power n. Clear? See here, this factor I am writing directly. 1 plus 1 by n to the whole to the power n. So this term becomes e, 1 by e, and this one 0, because the degree of denominator is greater than. So 0 into 1 by e, which is equal to 0, and 0 is less than 1. Therefore summation an is convergent. Clear? So this is the convergence of 1 by n to the power n. Now see, an is equal to 10 to the power n by factorial n. 10 to the power n by factorial n. An plus 1 by an limit n tends to infinity. It is equal to limit n tends to infinity an plus 1. That means 10 to the power n plus 1 by n plus 1 factorial, and I am taking the reverse, n factorial divided by 10 to the power n. So which now becomes limit n tends to infinity, 10 to the power n, 10 to the power n cancel out, remain 10. And here n factorial, n plus 1 factorial cancel out, remain n plus 1. So 10 by n plus 1, it will be equal to, tell me, 0, and which is less than 1. Therefore summation n is convergent. Clear? Now, another question, see here, n is equal to n factorial divided n to the power n into 2 to the power n. This one. Therefore limit n tends to infinity an plus 1 by an is equal to limit n tends to infinity n plus 1. What is n plus 1? Write it. N plus 1 factorial, it is 2 to the power n plus 1 by n plus 1 to the power n plus 1 into, convert it, n to the power n divided by n factorial into 2 to the power n. So here limit n tends to infinity, 2 to the power n, 2 to the power n cancel out. So in the numerator remain 2, and n factorial, n plus 1 factorial cancel out. So remain n plus 1. Then in the denominator it is n plus 1 to the power n plus 1 into n to the power n. Clear? Now see here. And cancel out n plus 1, it will become limit n tends to infinity. It is 2. I am writing directly. Divide n to the power n in the numerator and in the denominator. It will become 1 plus 1 by n whole to the power n. Because 1n plus 1, 1n plus 1 cancel out. N to the power n by n plus 1 to the power n. It will become 1 plus 1 by n to the power n as it is before. So it is equal to 2 by e. And the value of e is 2.71. So it is less than 1. Therefore, by ratio test, summation n is convergent. Clear? See here. Another question I am going to tell you. A n is equal to 1 by factorial n root over. This one. Root over of factorial n. So limit n tends to infinity n plus 1 divided by a n. Limit n tends to infinity, this one, 1 by n plus 1 factorial square root of this one divided by 1 by n factorial square root of this one. So just take this term to the numerator, it will become n factorial divided by n plus 1 factorial and take the square root. It will become limit n tends to infinity. After cancelling, it will become 1 by n plus 1 root over. So which is equal to 0. So 0 is less than 1. So the given sequence is summation n is convergent. Clear? The current electricity is not there. That's why I am feeling uncomfortable. Clear? So see here. Here a n is equal to 2n factorial whole square divided by 4n factorial into 10 to the power n. Clear? So limit n tends to infinity a n plus 1 by a n is equal to, see here, it will become limit n tends to infinity, this one. So 2 into n plus 1. 2n means 2 into n plus 1. Don't write 2n plus 1. Don't write like this, 2n plus 1 factorial. It is a wrong case. It will be 2 into n plus 1. 2 into n plus 1. That means 2n plus 2. Clear? So you should write here 2n plus 2 factorial, that is whole square, divided by, similarly 4 into n plus 1. It will become 4n plus 4 factorial. So already you have read these three conditions. You have remember. So see here, into 10 to the power n plus 1. So I am taking the reciprocal. It is 4n factorial divided 2n factorial whole square into 10 to the power n. See here, limit n tends to infinity. 10 to the power n, 10 to the power n cancel out. So remain 10. 10. Then this one I can write, see here, 2n plus 2, 2n plus 1, 2n factorial whole square divided by this one, 4n plus 4, 4n plus 3, 4n plus 2, 4n plus 1 into 4n factorial, and 4n factorial cancel with 4n factorial. Clear? Into this one, 2n factorial whole square. So if you will take the whole square, square of this one, square of this one, square of this one. So this factor cancel with this one. So remain, see here, limit n tends to infinity. So 10 into 2n plus 2, 2n plus 2, 2n plus 1, 2n plus 1 divided by 4n plus 4, 4n plus 3, 4n plus 2, 4n plus 1. And here the degree of numerator is same as that in the denominator. Same degree. Same degree. So the answer is 10. Coefficient of highest power of n is 2. Here it is 2. Here it is also 2. Here is also 2. Divided by 4 into 4 into 4 into 4. 4 cancel out, then another 4 cancel out. So remain 10 by 4 4 is 16. So it is less than 1. So summation n is convergent. Clear? See here, factorial 2 by 3 plus factorial 3 by 3 square plus factorial 4 by 3 to the 3 plus so on. Clear? So what is the nth term? You have to find out the nth term, that is an. See here, this is the first term, this is the second term, this is the third term. In the first term, it is 3 to the power 1. In the second term, it is 3 to the power 2. In the third term, it is 3 to the power 3. So, an is equal to, in the nth term, it will be 3 to the power n. In the first term, 3 to the power 1. In the second term, 3 to the power 2. In the third term, 3 to the power 3. So, in the nth term, it will be 3 to the power n. Clear? In the first term, it is written factorial of 2. In the second term, factorial 3. In the third term, factorial 4. That means 1 more than the number of term. Third term, it is written as 3 plus 1. Second term, 2 plus 1. First term, 1 plus 1. So, in the nth term, it will be n plus 1 factorial. Clear? So, this is an. Now, limit n tends to infinity, an plus 1 by an is your limit n tends to infinity, n plus 1 plus 1, it will be n plus 2, n plus 2 factorial, it is 3 to the power n plus 1 into, just take the reciprocal, 3 to the power n by n plus 1 factorial. So now it becomes limit n tends to infinity, 3 to the power n, 3 to the power n cancel out, and these two cancel out. In the numerator remain n plus 2 divided by 3. Here the degree of numerator is greater than that in the denominator, so it is equal to infinity, and infinity is greater than 1. So summation n is divergent. Clear? See here, another question. 1 square 2 square by factorial 1 plus 2 square 3 square by factorial 2, 3 square 4 square by factorial 3 plus so on. Clear? See here, this is the first term, this is the second term, this is the third term. In the first term, it is factorial 1. In the second term, it is factorial 2. In the third term, it is factorial 3. So, in the nth term, it will be factorial n. Clear? So, in the first term, so it is 1 into its next term. Second term, it is 2 into its third term, next term. Third term, 3 into its next term. So, in the nth term, it will be n square into n plus 1 whole square. This is an. Now, limit n tends to infinity, an plus 1 by an is equal to limit n tends to infinity, an plus 1. What is an plus 1? In place of n, write n plus 1. It will be n plus 1 whole square, n plus 1 plus 1, it will be n plus 2 whole square divided by factorial n plus 1 into, just take the reciprocal, factorial n divided by n square into n plus 1 whole square. So these two cancel out. So then limit n tends to infinity. These two also cancel out, remain n plus 1. So n plus 2 whole square divided by n plus 1 into n square. So degree of numerator is 2 and degree of denominator is 3. So denominator is of greater degree. So it means the value is 0 and which is less than 1. Therefore, summation n is convergent. Clear? See here. If the term contains simply one term in the numerator and one term in the denominator, 2 to the power n by n, like this. So blindly apply ratio test. Or if the nth term contains factorial, n factorial by n to the power n, or 2 factorial by 3 to the power something, like this. So blindly apply the ratio test. Ratio test is the easiest test. Okay. And I don't know whether my voice and the lines which I am writing, whether they are coincide or not. Clear? So today I will see whether or please comment whether my voice and the lines which I am writing, they are coinciding or they are deviating more and more. Okay. And if you have any doubt, then ask me. You can tell me, ask me any time, and I will give you the answer, reply. And I hope you have understood this ratio test. And now perhaps I will tell you today. I will tell you about the next class. Okay. And if the live class is okay, then it will be comfortable for me. And if the live class is not okay, then I have to do some videos. Okay, so please tell about something, that means whether the live class is okay or not, so that I can proceed or I can think about alternate way. Okay, thank you.
Something.